Hey folks, welcome back. In this video, we're going to finish our implementation of the stack in C. So what I want to do is basically finish implementing these different functions over here. So these are the ones we haven't done. In the previous video, we did the create, we did the destroy, we did the basic data structures. Now let's actually do the stack behavior. So let me start by basically making a copy of this. So I'm copying this, and then we're going to go over to our main stack file and just paste it in. So these are all things I need to build. Let me start by basically putting in my curly braces to indicate that all these are now going to be methods. So methods. Functions. It always drives me crazy jumping between the word function and the word method. But these are all functions here, right, because we're in C. All right, so these are our different things. What do we want to do? Let me think. Probably here, I think it would make sense to basically implement something like maybe like stack push and then like stack display, just so that we can maybe see some output of what this thing actually looks like. So let's start by implementing those two, push and display. So push. Well, we know what push does on a stack, right? We basically have a new element. We want to add it to the top of the stack. So what do we do over here? I know that my list is basically going to be structured as my stack is going to be structured as a list. So I probably need to do something like build a new node, right? So there was this node struct we did earlier. Probably we need to build a new node and then add it perhaps to that head of that list inside of the stack. So let's see. Let's do a node star, so a new variable. Call it new node, and we'll set that equal to a node star malloc size of node, right? So this is basically requesting new memory to store a node. So we have that there. So that'll build us a new node. Now what we got to do is we got to set up node, and then later on we got to attach node, right? So those are our different steps we need to take care of in order to actually add this new thing to the stack. So let's see, new node. So what do I want to do? I'm going to go new node, and let's see, what do I have to set up? I need to set up its element and its next. So how do I do that? Let's set up the element first. So new node. Arrow element equal element, right? So I'm going to save the element inside that node. Next thing I need to do is set up its next variable. So I'm going to go node, new node equal or arrow equal, next equal, and then here, right, I need to attach it to what's already there. So I'm actually have to go into that S variable, right? So the S variable is a struct that stores the constant stack. I need to open that up and do stuff inside of it. So I'm going to do S arrow, right, and then we'll do head. So basically what we're saying is the thing that comes after this new node is the existing head of the struct. All right, so that should do it for setting up the node, right? We have the data stored into it. We also have it linked to stuff that's already there. Well, the only things that remain for me to do is basically link it to the actual, update the stack with that new thing into it. Yeah, great grammar there, but it is late, so let's see what do we want to do here. So how do we attach it? Well, we need to basically update S, right? So S is our overall stack. So my stack, I basically want to update its head to be my new node, right? So this is now saying that the top thing in that stack is my new node that I've constructed. From there, we can go and say, what else do we need? Well, that should do it, right, for attaching to the stack. Probably the only other thing we need to do here is maybe increment the size variable, right? So I had a size variable inside my stack. There it is, stack. I probably want to increase that, right? Basically to keep track of how many things are inside of it. And so look at that. That looks pretty good to me, right? So I have a new stack, and then I have a new node, right? And then I set it up, attach it to the existing stack that I have. Okay, so that looks pretty good for push. So maybe I can think about, maybe calling this, right? So how does this look, right? If I call it, I'll have something like this. Let me see. Let's say I want to push in maybe some numbers. Let me push in perhaps. I want to push in. I don't know. We'll push 10, 15, and 20. How about that? Just push in some basic numbers. And of course, this should give me an error in a second. It's not. But why would it not work? I'm missing a parameter here, right? So let's go here. SID 10, SID 15, SID 20. Okay, so that's going to be to add stuff in. So actually, let's go ahead and build and compile this and see what we get. Okay, so it builds successfully. A couple of complaints here. Let's actually see what it's asking about. Expected void star by arguments of type int. Okay, so here, right, just looking back really quick. Stack push takes in a stack star as the first parameter and a void star as the second parameter. Well, this is pretty good. It's actually complaining about the second one. It's saying, oh, hey, you wanted a void star, but instead you gave me an int, which is going to be, well, that's what I want, right? I want to basically start by putting a bunch of integers into the stack, and then, storing them, right? So I'm actually going to do a cast here, right? So I'm going to say, okay, it's fine. Everything is fine. This is really just a void star, right? So I'm going to put in those. Okay. And let's just do a run, which will trickle compile as well. So it runs, everything looks good. Unfortunately, I can't really see any output, which is a little bit disappointing. So let's go ahead and add an extra call here. Let's do a display. Of course, that won't give us anything either because we haven't implemented it. But we'll see that it at least doesn't crash. All right, so we have our stack being pushed. We now want to implement display. So display basically loops through it and prints out everything in it, right? So display the contents of the stack as integers starting at the top. So let's see. Let me start by let me do printf. So I want to implement this now, right? That's where I'm going next. So I'm going to do my top, right? To basically say, oh, hey, this is the top of the stack. Otherwise, I get confused. This is the top or the bottom. What am I looking at? Okay, so I have that. What should I do? Well, I have a list inside of my stack, and I basically want to loop over everything in that list and display it. So first thing I'll do, right, is create basically a iterator variable to go over that list. So I'll do this, iter s arrowhead, right? So now I have basically this loop, or this iterator, right, that'll start at the first element of my list. It'll be up to me, of course, to move it forward. So let's see, what should I do? Well, iter not null, right? That means there is something to display. So we'll iter not null, do stuff. So we'll iter not null. We will go in here and we will say, well, we'll do a printf. We'll do a printf on basically that thing as a number, right? So I want to basically display the thing that's currently at the top of my stack. So I'll do this, and then I'll go iter arrow element. There we go. So that means basically look at the element and display it. Now I feel like it may complain again because this is basically the control symbol for an int, and this is a void star. So let me actually go ahead and add a cast there as well. So I want to say, hey, treat the element inside of it as an integer, right? Because I'm already saying, hey, that's what I want to do. So I want to display it just as integers. So I have this, okay. Then basically I need to move forward, right? So iter equal iter arrow next. And that should be good for us. That should display everything. Let's go ahead and compile it and see what we get. Compile, successful, run, and let's see if we get our values back. Okay, 20, 15, 10. Let's add in here. I forgot my /n, right? That was very important. Run this again. 20, 15, 10. I still need a /n. We'll jump back to main, compile this. Top 20. Okay, so top is 20, then 15, then 10. Well, the first thing we do is 10. That should be at the bottom, then 15, then 20. Oh, hey, it lines up, right? So it looks like everything there is working. We have basically the stuff being added to our stack properly. So that looks pretty good. Continuing on, let's maybe just add in maybe some other functions. So we have a couple more things we want to support. We need to do isEmpty, we need to do size, we need to do pop. So let's see. Some of these should be relatively easy. Let's see, like size. Well, size, I know that there's a size variable inside of my struct, so I can basically just go from S and go, okay, size, right? Done. Try it over here. We'll do something like our, let's see, what should we do? Printf, the stack contains $d for integer elements. And then we can go over here and do stack size of SID. Run this, and hopefully this tells me that the size of it is 3. Assuming that variable gets updated, it should be good. The stack contains 3 elements. Okay, that looks good. Let's see, what else do I want? So stack is empty. So what should I do here? Let's do a, well, we could use the size. We could use the size function, or we could just use the size variable directly. Probably using the size variable directly is going to be easier. So we'll go size equals 0, right? So I'm basically going to compare these and return them, right? So that will basically evaluate to a number, which then will be returned. Okay, so is empty. So then I can say over here, right? If stack is empty of SID, maybe then I'll do a printf. The stack is empty /n, and then else, right? Printf. I forgot my F over here. The stack is not empty /n. All right, we'll run this, and hopefully it says the stack is not empty. And I'm forgetting a semicolon because it wouldn't be a C video if I didn't forget that at least once. Okay, we're running that. Okay, the stack is not empty. Okay, cool. So it looks like that's working, and I will add one more /n. /n's and semicolons. It's kind of ridiculous sometimes. Okay, so we have those set up. What else do we want to do? We're almost done implementing this thing. Let's jump back over here. We also want to implement pop. So this is going to be our last function. So what should we do here? Let's go for pop. Okay, so pop, we'll go the following. So we'll go node. We'll call this active node. And what I want to do basically is, I know I need to remove a node from this. I know I need to remove a node from the list inside the stack. So I'm basically going to start by getting a reference to that head node. So active node equal s arrow head. Right. So let me grab that frontmost thing. Okay, that should be good. And then I'll go, next thing is I'll basically take out the data that it stores. So I'm going to go void star data equal active node arrow, reach inside of it, grab that element. Okay, so I grab the thing inside of it. Okay, that looks good. Let's see, I want to update the stack. Okay, so I'm taking this thing out. What I need to do, I need to update the pointer to the list that it contains, and I need to update its size. So first we'll update the list pointer. So the head, right, is going to be updated. It's now going to be basically the thing that follows the head, right? So s head equals s head, should be next, not element. Next, there we go. So basically update your head to be pointed at the next thing. Let's see, so we'll have that. Then we'll go s basically to size minus, right? So it goes down by 1. Okay, that looks good. My final line there is then going to be this. So I took out the first node, took out the data inside of it. Those are my first 2 lines. Then I updated the stack to basically have that thing be removed. And then my final thing basically is going to be to return my data, right? So return the thing that I took out of it. Okay, so that looks pretty good. Let's see. So this is just fine for a pop implementation. I'm going to add a couple more lines though, just for safety. I'm going to actually add something that looks like this over here. So let's go and say, actually, for pop, well, this is what I want. I want to basically say that, yeah, well, this is what we'll do. I want to actually deal with the case basically where it's an empty stack that we're operating on. So if let's see, if s size equals 0, or I guess I could call it as empty too, but this is maybe easier. Try to pop from empty stack. There we go. So we'll have that one little error message in there. Okay, so I think that should be good for pop. I'm not going to bother anything to push malloc. So we practiced with doing that once, right? But it really doesn't fail that often, so I'm going to leave that alone. Let's see, this looks pretty good to me. Let's go ahead and save this. And maybe we'll try a few more manipulations. So right now we add 3 things, display it, put the size of it. Let's maybe do let's do that, and then perhaps something like, we'll go do stack pop of SID. And we'll do like this. We'll do the output, right, is x equal to, and we'll cast as an integer. Because when it does a pop, it'll return a void star, but it's really just an integer. So that basically should take out the x value. So let's see. After that, I can do this. We'll do a display again, and then a stack size again. Right, we'll display that, and then we'll do, just for good measure, the popped value. The popped value was, and we'll use that x. Okay. So hopefully, right, this displays our original stack in size 3, and then if everything else works, this will basically display a stack that only has 2 things in it, the 10 and the 15. It'll tell me it only has 2 elements, and then it'll show me the pop one is 20. Right, so if all goes according to plan, that's what I should get. Let's go ahead and run that. See what we get. Let's see, this is the first time, and the second time we get the top, 15, 10. Okay, looks good. Returns 2. The popped value is 20. Stack is not empty. Except for that missing new line, everything looks good. So let's go ahead and do that, and that new line there. And then perhaps we'll just do a couple more pops. So we'll do a pop, and another pop, and hopefully we can trigger that empty message at the very end. Let's go ahead and run this, and hopefully it works. There we go. The stack is empty. All right. So yeah, well, this is some test code. Right? So we have some decent tests here, right? So we've testing push, pop, display, empty, size, create, destroy. We're testing everything here. Everything looks good. So this basically, right, is me having an object, right? So this is as if I created a new object, did a bunch of manipulation on it, right? Imagine you're doing that dot operator in Java, and that is stored at the end of the day, right? The automatic garbage collection equivalent. So yeah, that looks good, right? We have our specification from our first video, right? That was looks pretty good. Our implementation over here looks pretty good too. So yeah, at this point, it looks like we've implemented a stack in C. So there you go. That's actually it, right? So this is now an object, right, that we've implemented in C using just the normal support for functions. All right, so that's all I got for you guys in this video. At this point, it's kind of late. So yeah, that's all I got, and I will see you guys in the next set of videos.